Hey everybody, for today's video I will be covering conditional probability. I'm pretty sure a majority of you guys are familiar with this formula over here for union, which is just the probability of A plus probability of B minus their intersection. And right here we have the probability of A given B. So they're just asking what is the chances that, for example, Alice gets to go to the mall if her parents are in a good mood. Now you'll have the probability of her going to the mall, as well as the probability of whether her parents are in a good mood that day. The formula is simply the intersection divided by the given probability. These two equations right here, I believe a majority of you guys haven't seen since like grade 10 probably. This C right here represents not, essentially. So what's the probability of A not occurring? It's simply 1 minus the probability of A. Similarly, the probability of A not occurring given B is occurring is just 1 minus the probability of A given B. Now let's look at this question right here. It is question 1 for section 4 and probability of the course revision sheet. It will use all the formulas we just discussed. Given in a sample space as two events A and B such that the probability of A is 0.6 and probability of B is 0.75. With their union is 0.9. Watch out for if they use union or intersection. Find the probability of A given B and A not occurring given B. So as you can already tell, for A given B, you need their intersection, which you do not have as a given currently, but you can find it using this formula right here. So their union 0.9 is equal to the probability of A plus the probability of B minus their intersection. If you were to calculate this, your answer would be 0.45. Then you can solve for A given B, which is 0.45 divided by the probability of the given value, 0.75, and you'll get 0.6. Now, what's the probability of A not occurring given B is occurring? We already discussed this earlier. It's simply 1 minus probability of A given B. So 1 minus 0.6, which is 0.4. There you go. Now I'd like to cover a few significant events, which is independent events, mutually exclusive events, and exhaustive events. Independent events means that the probability of one event occurring does not affect the other. For example, if I were to roll 1 dice and I get a 2, this does not affect what number I'll get if I roll it again. Just because I got a 2 the first time doesn't mean I have a better chance of getting, for example, a 6 the second time. There is no correlation between each events occurring. The two formulas for independent events is their intersection is simply the product of their probabilities, and A given B is simply A, or B given A is simply B, because as I already stated, if one event is occurring, it does not affect the other whatsoever. Now, looking into mutually exclusive, it just says that they have no coinciding events. If A were to occur, B would probably not occur at the same time, so their intersection is 0. Exhaustive is the opposite. So their union is 1. They're always occurring together. Exhaustive probably won't come as often as, for example, independent events or mutually exclusive, but there might be a question or two regarding it. Now let's look at a few questions. Oh, right here. Alright. A fair die is rolled twice. Which of these events is more likely to occur? Getting a sum of 8, getting an even number on the first throw, or getting a sum of 8 knowing that the first throw is an even number? Now, sadly, for questions such as this, you might have to write all the possible events that may occur. So 1 1, 1 2, 1 3, 1 4, 1 5, so on and so forth. And then you find right here all the values that give you 8, which is 6 2, 5 3, 4 4, 3 5, and 2 6. This is your sample space for getting a sum of 8, all of these. So you have 5 possible events that will give you 5, divided by the total number, which in this case is 36. This is the probability of getting a sum of 8. Now let's look at question B, getting an even number on the first throw. This will jump back to what I explained in independent events. As already said, the probability of one occurring does not depend on the second, so you can just find the probability of getting an even number from just a single throw. So you can get either 2, 4, or 6, and you have a data number of 6 in total. So 3 events, which is 2, 4, and 6, divided by a total 1, 2, 3, 4, 5, 6. If you simplify, 1 over 2. That's the probability of getting an even number on the first throw. Now C is getting a sum of 8 knowing that the first throw is an even number. Honestly, since you already wrote all the values down here, the numbers that you can get 8 with that have the first throw even is 6 and 2 right here, 4 and 4, and 2 and 6. So this right here is their intersection, because you have both an even number and the sum of 8. So the probability of A, let's say A is a sum of 8, intersection B is 1, 2, 3, divided by 36, the total number. Now, what is the probability of getting a sum of 8 knowing you already know that the first throw is an even number? So they're basically just asking A given B. As you already stated, it's their intersection, which we just got 3 over 3, 6, divided by the probability of the second value, or the given value. In this case, the given is even, so the probability of getting an even number, 1 over 2. If you were to calculate this, you would get 1 over 6, and that's your answer. So out of A, B, and C, which of these events is most likely to occur? So which has the highest probability? It's clear to see that B has the highest probability at 50%, so B would be your answer. That will be it for this video. Thank you guys for watching. I hope you learned something, and yeah, thank you for watching.